So far in this worksheet, we talked about just very basically what is direct translation. Remember, direct translation is the process of converting words to math, and with indirect translation, our goal is to assign a variable to what we don't know. Now we're going to expand on that, and we're going to start talking about what some people call story problems. We're going to start really basic with the first example, and then the second example, we're going to have like kind of more of a real world scenario, okay? So topic 2 is all about problem solving. Remember, that's a secret way in math of us just saying word problems, okay? So steps used in problem solving. Understand the problem. That can sometimes feel like the hardest part, but really just understand basics, what's happening. Okay, start by reading the problem thoroughly to understand what is being asked. Sometimes you have to read these word problems 3, 4, 5 times to kind of get a grasp of what's going on. Some of them are pretty easy, some are a little more involved. Okay, but take the time. Don't rush through reading the word problem. Read it slowly, read it a few times. Translate the problem. Sometimes when it comes to translating the problem, this can be a multi-step process. You sometimes will take the word problem and you'll just condense it down. Like you take out all that extra stuff that you don't need. So you'll start by kind of writing an equation, but almost in words, and then you take that very simple statement and then convert it to the actual equation. Okay. So the translate part can be involved. Okay. So it says translate the problem, write the problem in short form using words, and then assign a variable. Okay. So again, translate can be a couple of steps. Convert it to a really condensed short statement using words, then convert those words to the equation. And then step 3 is solve the problem. That's the easy part, honestly. Like we already know how to solve equations. So once you get the equation, it's generally not hard to solve it. It's getting the equation that can be the tough part. So it says solve the problem, perform the indicated operations. Estimation can be used to get an idea of what the actual solution might be. So sometimes if you just sort of think in general about the problem, you can get a good idea pretty quickly if your answer is like way off the mark. You can be like, that doesn't make a lick of sense right here. So using the idea of estimation and just general good number sense, you can sometimes tell if your answer is like on track with being correct or if it's completely off the wall. And then finally, interpret the results. Remember, anytime you have a word problem, you always have to describe your answer. You can't just leave a number. Numbers don't mean anything when it comes to these word problems until you describe what that number is. So interpret the results, check the solution to the problem, and then state your conclusions. Write your results with correct units. So remember, at minimum, you need to have a number with a unit. At best, or even better if you can kind of describe your answer. Okay, so let's get started. The first 2 examples are going to be just really, really basic. They're going to be kind of like what we did in the first video. And then the second example, we're going to get a little more involved. Okay, so example 3 for this worksheet says translate each sentence to an equation and solve. Let X represent the unknown number. Again, I'm a big fan of X. I tend to always use X. It can be other variables, though. You could use really any variable. I just tend to go with X. So it says 5 times a number decreased by 3 is equivalent to, notice we have those words right off the bat that means equals, okay? And this is equivalent to the difference of twice a number and 18. So let's look at everything before is equivalent to. That's going to be the left-hand side of the equation. Everything after is equivalent to is going to be the right-hand side of the equation. So before is equivalent to, we have 5 times a number. That's easy. That's just 5 times x. We don't even have to write the multiplication. We just write the 5 and the x side by side. The multiplication is understood. So we get 5x. But we want to decrease that by 3. Decrease would indicate a subtraction. So we're going to subtract 3. Now we're to that part that says is equivalent to. That's just equals. And then after is equivalent to, we have the difference. So we're talking subtraction of twice a number. So we want 2 times a number. So again, just x and 18. Now the difference of 2 times a number and 18 is going to be 2x minus 18. Now, in this case, we are going to solve. The directions don't explicitly say it, which I should probably add that here, but because we're doing problem solving, we're actually going to solve this right here and determine what that unknown value is, okay? So in order to solve an equation, this one's pretty basic. We want to get at most 2 terms on each side first. So you have at most 1 variable term, 1 constant term on the left, at most 1 variable term, 1 constant term on the right. Once you get to that point, then you can start applying the addition property of equality. That means moving stuff with addition or subtraction across the equal sign. I like to always start with my variables. So I've got 5x on the left, 2x on the right. I'm going to move the 2x from the right to the left. Now, 2x is positive, so think of that as like plus 2x. How do we undo addition? Well, we use subtraction. So I'm going to subtract 2x. So on the left, I'm going to combine like terms. 5x minus 2x is 3x. We just take 5 minus 2. And then just don't forget to drop down your minus 3 and your equals. And then on the right, my 2x's cancel. 2x minus 2x is just 0. 0 minus 18 is negative 18. Okay, so what's really cool about that step is I've got all of my variables in a single term. Now I need to isolate that term. So now to isolate the 3x, my issue is minus 3. So how do I undo subtraction? With addition. So I'm going to add 3 to both sides. Make sure whatever you do to the left, you do to the right and vice versa. That helps us maintain balance. So I'm going to add 3 to both sides. Over here on the left, negative 3 plus 3 is just 0. 3x minus 0 is 3x. And then on the right, negative 18 plus 3 is negative 15. Now I'm going to move this whole problem kind of up here so I have more room. So I have 3x minus 15, or 3x equals negative 15. Hold on, I just got kind of crazy there. Now, at this point, I've got a single variable term equaling a single constant term. That tells me it's time to apply the multiplication property of equality. So I need to undo the multiplication of 3 and x at this point. So I undo multiplication with division. So I divide both sides by 3. On the left, 3 divided by 3 is 1. 1 times x is positive 1x, okay? And then finally, negative 15 divided by 3, that's just negative 5. So I would say my final answer here is just 5. Since there's not like a real world scenario going on, there's not really any other way to describe the answer other than to say, now we know x is negative 5. Okay? Part B, very similar. Okay, it's just a simple statement. We don't really have a story going on here, but we do have 3 times the difference of, hold on, I have a picture in the way on my screen. So it says 3 times the difference of a number and 1 equals 12. So we want 3 times an entire difference, okay? So we want 3 times a whole difference. So we want a difference in parentheses. So the difference is going to be of a number and 1, and that equals 12. So let's go ahead and deal with the before the equals. So before the equals, we had 3 times the difference of a number and 1. Well, we want 3 times the whole difference, and the difference is just between a number and 1. So x minus 1 equals, means the equal sign, and then just 12 is 12. So now in order to solve this equation here, we are going to need to distribute first. So in order to solve, I want to take this 3, I'm going to multiply it by the x, and then I'm going to multiply it by the negative 1. I do that first, okay? So 3 times x is 3x. 3 times negative 1 is negative 3, and that all equals 12, okay? Now, luckily, I only have one variable term in this entire problem, so I'm going to still have to apply the addition property of equality, but I'm only going to have to do it once. I need to get this 3x term alone. So my issue now is the minus 3, which this is starting to feel very familiar. This was by accident. It was a poor choice of a problem, but I do want to get the 3x alone. We need to deal with minus 3. In order to deal with minus 3, I add it. So I'm going to add 3 to both sides of the equation, and that moves the minus 3 from the left to the right. On the left, negative 3 plus 3 is 0. 3x minus 0 is 3x. On the right, 12 plus 3 is 15. And this should look at least a little bit familiar. We have 3x equals 15. I now need to apply the multiplication property of 0. I need to undo the multiplication of 3 and x. So I would divide both sides by 3. On the left, 3 divided by 3 is 1. 1 times x is x. And then on the right, 15 divided by 3 is 5. So we get positive 5 instead of negative 5. That was an accident. I should have picked a different question. But here again, there's no real way to describe the answer other than now we know x is equal to positive 5. Okay? It's example 4 that's going to be a bit more involved. This is the true problem solving right here. This is where we have a real world, like, story problem. Okay? So example 4 says translate each scenario into an equation and solve. Okay? So for part A, I was clearly watching The Office when I came up with this problem. Jim and Pam saved $56. So we know right now between Jim and Pam, if they add up all of their savings, their piggy banks or whatever, they have $56. So we know that, okay? Jim saved $8 more than Pam, okay? How much did each person save? Now, here's the issue. A lot of you are bright, you can think, you're awesome, okay? You can sort of play around with numbers and tell how much Jim and Pam each saved so that they saved a total of $56 where Jim saved $8 more than Pam. The issue is you're in an algebra class. I'm not interested in you magicking the answer out of thin air. I want to see your algebra. Okay, so you need to get used to showing the algebra, even for an easy example like this, where you can just sort of play around for a minute or two and figure out the answer. We still want to see the algebra. Okay, so here's how I do problems like this. This is my method. If it works for you, great. If you want to tweak it to make it work for you a little differently, also great. I know that if I take the savings that Jim had and add it to the savings that Pam had, I'm going to get a total of $56. I know that. That's easy. Jim and Pam combined save $56. Now, we know that Jim saved $8 more than Pam. That tells me I know nothing about what Pam saved. So what I'm going to do is I'm going to assign my variable to Pam. I'm going to say, okay, Pam saved X dollars. So of those $56, X of them were Pam's. We know that Jim saved $8 more than Pam. So that means he saved X dollars, the same amount as Pam, plus 8 more. Okay? So Jim is now going to be the expression X plus 8. Pam is going to be the expression X. And if I combine like terms in this column right here, X plus X is 2X, and then plus 8 is just plus 8. So now I have an equation to solve. If I can solve this equation right here for X, I'll know how much Pam saved, and I can use that to determine how much Jim saved. Okay? So I've got 56 equals 2X plus 8. I've got that single variable term. I want to isolate it. My issue is plus 8. So at this point, hopefully you're pretty good at understanding the way we undo addition is subtraction. So I want to subtract 8 from both sides of the equation. Well, on the right, we have 2x plus 8 minus 8. Well, 8 minus 8 is just 0, and 2x plus 0 is just 2x. On the left, we have 56 minus 8, which is what, 48? So now we have 48 equals 2x. I need to undo the multiplication of 2 and x, so I divide both sides by 2. 2 divided by 2 is just 1. 1 times x is x. And then 48 divided by 2 is 24. You are not done. I've had students in the past that they solve for x and they think they are done. No. You have figured out what x is, but you still have to relate this back to the problem. So now I like to just check everything. Well, I know that X was how much Pam saved, which we now know X is $24. We also know that Jim saved X, which is 24, but 8 more than that. So he saved 24 plus $8, which means he saved what, $32? So now let's go ahead and add 32 and 24. And what should it add up to? Hopefully everybody was like 56. Okay. So 32 plus 24, we want to add. 4 and 2 is 6. 3 and 2 is 5. We get the 56. So now we have to describe our answer. So we would want to say something like, Jim saved $32 and Pam saved $24. So just a quick description. So again, once you solve for X, you're not necessarily done. You have to go back and relate that X to the rest of the problem and then check your answer. It's always wise to check your answer with a word problem and then just make sure you describe your answer. So again, I started out with words. I converted words to algebra. I solved and then I checked everything and then I described my answer. Okay, so let's look at part B. So in part B, we have a 12-foot board that is cut into 2 pieces. The longer piece is 3.5 feet longer than the shorter piece. What is the length of each piece? So this is very, very similar to the Jim and Pam problem, okay? I know I have a longer piece of the board plus a shorter piece of the board. And if I put them end to end, they have to equal 12 feet, which was the original length of the single board. So if I take the longer piece plus the shorter piece, it has to equal 12 feet. Okay, so now let's talk about the variable. We always assign the variable to what we don't know. So if we go back to the problem, it says the longer piece is 3.5 feet longer than the shorter piece. That means I don't know anything at all about the shorter piece. Okay, so I'm going to go ahead and let the shorter piece take the variable x. Now that means the longer piece is x feet plus 3.5 more. Okay. So the shorter piece is x feet. The longer piece is x feet, but a little bit longer than that by 3.5 more feet. Okay. So if I combine like terms in this second column, I get x plus x is 2x, and then drop down my 3.5x. And now, again, I have an equation that I can solve. If I can solve this equation for x, I'll know the length of the shorter board. I can then apply that to figure out the length of the longer board, and I can check my work. Okay, so the first thing I want to do is get this 2x alone. The issue is plus 3.5. To move the 3.5, I subtract it. Okay, so 12 minus 3.5, we would get what, 8.5? And then that's going to equal just 2x. And the reason it equals just 2x is 3.5 minus 3.5 is 0. 2x plus 0 is 2x. So now I want to get the x alone. The issue is x has been multiplied by 2, so I need to undo that multiplication. So I divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. And then 8.5 divided by 2 is 4.25. You are not done. You're ready to check your work. So we know the shorter piece is 4.25 feet. We now have to use that to figure out the length of the longer piece. So I know the shorter piece is 4.25 feet. The longer piece is 4.25 feet plus 3.5 more. So if I take 4.25 and I add 3.5, that's going to give me 7.75 feet. Okay, so right now we're speculating that the longer piece of the board is 7.75 feet. The shorter piece is 4.25 feet. Let's go ahead and add these two numbers and make sure it adds up to be the original 12-foot board that we had. Okay, so when you add decimals, you just line up the decimal point and then add column by column. So 5 plus 5 is 10. So I keep a 0, carry a 1. 2 plus 7 plus 1 is 10. That's a 10, I swear. Let me fix that. So 1 plus 7 plus 2 is 10. I keep a 0. I carry a 1. Don't forget to drop down your decimal point. And then 1 plus 7 plus 4. Well, 1 and 7 is 8. 8 plus 4 is 12. Sure enough, we get that the sum of these two boards, the longer and the shorter piece, really does equal 12 feet. So I would say the longer piece is 7.75 feet, and the shorter piece is 4.25 feet. Make sure you always describe your answer. Okay, so we've done quite a bit in this video or in this worksheet so far. We just remind ourselves of basic direct translation, so creating expressions and equations from words. We then looked at another situation where we created equations from words, and then we went ahead and solved, and then we looked at these two word problems. Okay, coming up, we're going to look at additional types of word problems.